According to the National Electrical Code, specifically Section 250.104b, metal water piping systems must be bonded to the electrical grounding system under certain conditions. The primary reason for this requirement is to minimize the risk of electric shock. If a fault occurs within the electrical system, stray current could potentially flow through metal water pipes. Bonding provides a low impedance path back to the electrical source, allowing the overcurrent protection device, such as a circuit breaker, to trip and clear the fault. This significantly reduces the potential for electric shock. Section 250.104b specifically addresses the bonding of metal water piping. It states that metal water piping systems that are likely to become energized shall be bonded to the service equipment enclosure, the grounded conductor at the service, the grounding electrode conductor if of sufficient size, or to one or more grounding electrodes used. The bonding jumper must be sized in accordance with Table 250.102 cone, and the bonding conductor must be sized in accordance with Table 250.66. The code provides an exception number 1 to Section 250.104b, which is important to understand. It states that bonding is not required where the metal water piping system is effectively grounded through connection to a metal underground water piping system that is at least 10 feet or 3.5 meters in length, including any supplemental electrodes. In simpler terms, if the metal water pipe is directly connected to an underground metal water pipe that is at least 10 feet long, it is considered effectively grounded and does not require additional bonding. However, this exception does not apply when the underground water pipe is non-metallic, such as PVC. The presence of a short section of copper pipe within a predominantly non-metallic water system raises a crucial point. Even a small length of metal pipe, such as the 3-foot section of copper, can introduce a potential shock hazard if it is not properly bonded. The code does not provide exemptions based on the length of the metal pipe, as long as it is less than 10 feet from a potential electrical source. Therefore, despite its short length, the copper pipe must be bonded to the electrical grounding system to ensure electrical safety. The size of the bonding conductor is determined by the size of the service entrance conductors. Table 250.66 of the NEC provides guidance on the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. In this case, this service is being upgraded to 800 amps. Based on the 800 amp service, the minimum size of the bonding conductor to the copper water pipe would be determined by referencing Table 250.66. The conductor should be copper unless otherwise permitted by the code, and should be installed in a manner that protects it from physical damage. The point of connection for the bonding conductor should be accessible and made using approved methods, such as a bonding clamp listed for the purpose. Proper installation and adherence to the NEC are essential to ensure the effectiveness of the bonding and the safety of the electrical system. Bonding is a critical safety measure that helps to protect people from electric shock. By connecting metal water pipes to the electrical grounding system, any stray current is safely diverted back to the source, tripping the circuit breaker and preventing a potential hazard. Always consult the latest edition of the National Electrical Code and local amendments for specific requirements and guidance on electrical installations. It's always advisable to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. To elaborate further, the purpose of bonding metal water piping is to create an equipotential plane. This means that all metal parts within the building are at approximately the same electrical potential. This minimizes the voltage difference between different metal parts, reducing the risk of electric shock if a person comes into contact with two different metal surfaces simultaneously. In the absence of bonding, a voltage difference could exist between the metal water pipe and other grounded metal objects, such as appliances or equipment. This voltage difference could drive current through a person's body if they touched both objects, resulting in an electric shock. Bonding effectively eliminates this voltage difference, making the electrical system safer. It is also important to note that the bonding connection must be made on the consumer side of the water meter. This is because the water meter may contain non-conductive parts that could interrupt the continuity of the grounding path. The bonding connection should be made as close as practical to the point where the water pipe enters the building. Additionally, the bonding conductor must be protected from physical damage. This can be achieved by running the conductor through conduit or other protective means. The conductor should also be securely fastened to both the water pipe and the electrical panel. The NEC also addresses the bonding of other metal piping systems, such as gas piping. Section 250.104 requires that metal gas piping systems be bonded to the electrical grounding system. The requirements for bonding gas piping are similar to those for water piping. The bonding conductor must be sized in accordance with Table 250.102 cone and must be installed in a manner that protects it from physical damage. The purpose of bonding gas piping is also to minimize the risk of electric shock. If a fault occurs and electricity flows through the gas piping, bonding provides a low impedance path back to the electrical source, tripping the overcurrent protection device. This significantly reduces the potential for electric shock. In addition to bonding metal piping systems, the NEC also requires the bonding of other metal parts that are likely to become energized. Section 250.96 requires that all metal parts that are likely to become energized be bonded together to form an effective ground fault current path. This includes metal enclosures, metal raceways, and metal equipment. The bonding connections must be made using approved methods, such as bonding jumpers or bonding screws. The purpose of bonding these metal parts is to provide a low impedance path for fault current to flow back to the source. This allows the overcurrent protection device to trip and clear the fault, minimizing the risk of electric shock. In summary, bonding is a critical safety measure that helps to protect people from electric shock. By connecting metal parts to the electrical grounding system, any stray current is safely diverted back to the source, tripping the circuit breaker and preventing a potential hazard. Adherence to the NEC and proper installation techniques are essential to ensure the effectiveness of bonding and the safety of the electrical system. Always consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. Also, it is crucial to understand the difference between bonding and grounding. Grounding refers to connecting the electrical system to the earth, providing a reference point for voltage and helping to stabilize the system. Bonding, on the other hand, refers to connecting metal parts together to create an equipotential plane, minimizing voltage differences and reducing the risk of electric shock. Both grounding and bonding are essential for electrical safety, but they serve different purposes. In the context of the question, the focus is on bonding the copper water pipe, which is a specific application of the broader concept of bonding metal parts. The requirement to bond the 3-foot section of copper pipe highlights the importance of considering all metal parts within the electrical system, even small sections, to ensure electrical safety. The code does not provide exemptions based on the length of the metal pipe, as long as it is less than 10 feet from a potential electrical source, emphasizing the need for diligence and attention to detail when installing electrical systems. Furthermore, it's important to consider the potential for future modifications or additions to the water system. If the water system is modified in the future and the copper pipe is replaced with non-metallic pipe, the bonding conductor may no longer be required. However, it is important to reevaluate the situation whenever changes are made to the electrical or plumbing systems to ensure that all applicable codes and regulations are being followed. The installation of ground fault circuit interrupters, or GFCIs, is another important safety measure that can help to protect people from electric shock. GFCIs are designed to detect even small amounts of current leakage to ground and to quickly interrupt the circuit, preventing a potentially fatal shock. GFCIs are typically required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. While GFCIs are not a substitute for proper bonding and grounding, they provide an additional layer of protection. It's also important to ensure that all electrical equipment is properly listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or OL. Listing and labeling indicate that the equipment has been tested and meets safety standards. Using listed and labeled equipment helps to ensure that the electrical system is safe and reliable. In addition to the specific requirements for bonding metal water piping, the NEC also includes general requirements for grounding and bonding electrical systems. Article 250 of the NEC covers grounding and bonding in detail, providing guidance on the proper methods for grounding and bonding electrical systems. It is essential to consult Article 250 for complete information on grounding and bonding requirements. Proper grounding and bonding are essential for electrical safety. By following the requirements of the NEC and using approved methods and materials, you can help to ensure that the electrical system is safe and reliable. Always consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electric shock. If you are not qualified to perform electrical work, it is best to hire a licensed electrician to do the work for you. In addition to the technical aspects of bonding and grounding, it is also important to consider the human element. Electrical safety is everyone's responsibility, and it is important to educate people about the dangers of electricity and how to prevent electric shock. This includes teaching children about electrical safety, using ground fault circuit interrupters in areas where there is a high risk of electric shock, and avoiding the use of damaged or frayed electrical cords. By promoting electrical safety awareness, we can help to prevent accidents and save lives. Furthermore, the inspection process plays a vital role in ensuring electrical safety. Electrical inspectors are responsible for verifying that electrical installations comply with the NEC and other applicable codes and regulations. The inspection process helps to identify potential hazards and to ensure that the electrical system is safe and reliable. It is important to cooperate with electrical inspectors and to address any issues that they identify. In conclusion, bonding metal water piping is a critical safety measure that helps to protect people from electric shock. The NEC requires that metal water piping systems be bonded to the electrical grounding system under certain conditions. Even short sections of copper pipe must be bonded, regardless of their length. Proper installation and adherence to the NEC are essential to ensure the effectiveness of bonding and the safety of the electrical system. Always consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. Remember that electrical safety is everyone's responsibility, and it is important to take all necessary precautions to protect yourself and others from electric shock. The 1/0 conductor requirement is not arbitrary, it is calculated to handle potential fault currents. The size is based on the service entrance conductor size. Table 250.66 dictates the minimum size for grounding electrode conductors, which is often used as a reference for bonding jumpers. It's crucial to use a listed bonding clamp for the copper pipe to ensure a secure and reliable connection. The clamp should be made of a material compatible with copper to prevent corrosion. Clean the copper pipe before attaching the clamp to ensure good contact. Dielectric unions are sometimes used to connect to similar metals in plumbing systems to prevent galvanic corrosion. However, a dielectric union should never be used as a substitute for proper bonding. The bonding conductor must bypass the dielectric union to maintain electrical continuity. In older homes, the metal water piping system may have been used as the primary grounding electrode. However, this is no longer permitted by the NEC. A separate grounding electrode, such as a ground rod or ground ring, is required. The metal water piping system can be used as a supplemental grounding electrode if it meets certain requirements. Regular inspections of the electrical system are important to identify any potential problems. Check the bonding connections to ensure that they are still secure and that there is no corrosion. Replace any damaged or corroded components immediately. When working on electrical systems, always energize the circuit before starting work. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Never work on electrical systems while standing in water or on a wet surface. Consider the corrosive environment. Churches in rural areas sometimes have water with high mineral content, which can accelerate corrosion of metal piping and connections. Use corrosion-resistant materials and regularly inspect the bonding connections. Ensure that the bonding conductor is protected from physical damage. It should be routed in a way that prevents it from being accidentally cut or damaged. If the conductor is exposed to physical damage, it should be protected by conduit or other means. When upgrading an electrical service, it's important to ensure that the grounding and bonding system is also upgraded to meet the new requirements. This may involve installing a new grounding electrode, upgrading the size of the grounding electrode conductor, and upgrading the size of the bonding jumpers. The electrical inspector will verify that the grounding and bonding system is adequate for the new service size. If the church has a lightning protection system, it's important to ensure that the grounding and bonding system is coordinated with the lightning protection system. The lightning protection system should be bonded to the electrical grounding system to provide a common ground reference. The electrical system should be inspected annually by a qualified electrician to ensure that it is safe and reliable. The inspection should include a visual inspection of the grounding and bonding system, as well as testing of the ground fault circuit interrupters. Keep records of all electrical work that is performed, including inspections, repairs, and upgrades. These records can be helpful in troubleshooting problems and in demonstrating compliance with codes and regulations. Educate church staff and members about electrical safety. Teach them how to recognize potential hazards and how to prevent electric shock. Post electrical safety reminders in prominent locations. By taking these steps, you can help to ensure that the electrical system is safe and reliable for everyone at the church. Electrical codes and regulations are constantly evolving. Stay up to date on the latest changes to the NEC and other applicable codes and regulations. Attend continuing education courses and seminars to learn about new technologies and best practices. Join a professional organization such as the International Association of Electrical Inspectors or IE to network with other electrical professionals and stay informed about industry trends. By staying informed and involved, you can help to improve electrical safety and to protect people from electric shock. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. Check with the local building department to determine the specific requirements in your area. The local building department may have additional requirements for grounding and bonding, such as requiring the use of specific types of grounding electrodes or requiring additional bonding connections. It's important to comply with all applicable codes and regulations to ensure that the electrical system is safe and reliable. Working on electrical systems can be dangerous. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the work for you. A licensed electrician has the training and experience necessary to perform electrical work safely and in compliance with codes and regulations. When hiring an electrician, check their credentials and make sure that they are licensed and insured. Ask for references and check them to make sure that they have a good reputation. Get a written estimate before the work begins and make sure that you understand the scope of the work.